38 tons of titanium and thrust. In the airspace above South Asia, this silhouette represents the heaviest presence on the radar screen, a machine that defines the regional standard for air superiority. This is the Su-30MKI. With a fleet of nearly 260 active aircraft, it is the undisputed heavy-hitting backbone of the Indian Air Force. It did not roll off a standard single-nation assembly line. The power of this aircraft comes from the fact that it is a highly customized, multinational hybrid pieced together from competing design philosophies. In the 1990s, the collapse of the Soviet Union left its legendary aerospace industry starved for cash. At Sukhoi, production lines halted and staff went unpaid. Simultaneously, the Indian Air Force faced a strategic crisis. They urgently needed a heavy, next-generation fighter with the range and payload to secure their massive borders. New Delhi refused to purchase existing off-the-shelf Russian stock. They proposed a joint venture requiring radical, ground-up modifications to the base airframe. The resulting contract injected crucial funding that kept Sukhoi alive during a turbulent era. In return, the factory began fabricating the modernizirovanny Kommersky Indiski, a platform designed specifically for India. By dictating the architecture of the jet, India transitioned from a standard customer purchasing foreign weapons into a co-developer of a heavy fighter platform. This document details the Su-30MKI's structural specifications. The airframe is built from Russian titanium and high-strength aluminum alloys. Below, the specifications highlight the AL-31FP engines. Their exhaust nozzles pivot independently, allowing the massive jet to execute extreme maneuvers by redirecting thrust. But inside that heavy Russian metal sits an entirely different, highly sensitive operating system. The cockpit is wired with French navigation displays and heads-up targeting systems. Those components are directly linked to electronic warfare modules designed and built in Israel, forcing Russian flight controls to communicate seamlessly with French and Israeli electronics required a central translator. The Indian Vetravali project engineered a custom mission computer to sync these disparate hardware philosophies. Synthesizing these technologies created a highly agile hybrid machine, a Frankenstein of the skies, remaining one of the most distinctive multi-role jets in modern warfare. A heavy airframe originally designed for air superiority also provides an immense payload capacity for long-range strike missions. Engineers modified the aircraft's undercarriage to perfectly integrate the massive BrahMos cruise missile. Traveling at Mach 3, an air-launched BrahMos allows the jet to execute devastating kinetic strikes against land targets and naval vessels. The Air Force stationed a squadron equipped with this payload at Tanjavur. From there, the jets monitored traffic flowing through the Malacca Strait, providing a check on Chinese naval movements in the Indian Ocean. Attaching a heavy cruise missile to the MKI shifted the balance of regional maritime power, turning a fighter jet into an ocean-dominating threat. In February 2019, the fighter platform faced a very high-stakes stress test during the sudden aerial clashes over the region of Balakot. The conflict exposed a critical capability gap. Pakistani F-16s, using American-supplied AMRAAMs, could launch attacks from beyond 100 kilometers. This severely outranged the older 80-kilometer Russian missiles that were then mounted on the Indian jets. The Indian Air Force responded with an accelerated upgrade program. They integrated the Israeli I-Derby extended-range missile to neutralize that distance advantage. Simultaneously, they deployed the indigenous Astra Mark I. This domestically developed beyond visual range missile features high resistance to electronic jamming. Because the Su-30MKI runs on an open, customizable architecture, it could rapidly absorb these new weapons to survive an evolving regional threat. Utilizing that hardware requires enduring intense physical punishment. When the exhaust nozzles pivot to force the jet into a sudden directional shift, the pilot absorbs a massive, punishing spike in G-forces. Managing that strain is only part of the job. The pilot must also process targeting data from French screens, Israeli jammers, and Russian flight sensors simultaneously in the middle of a contested electronic environment. In that chaos, the crew places absolute trust in the Indian-designed radar warning receivers and display processors to maintain situational awareness. The engineering provides the raw capability, but the true lethality of the platform lies in the human operators mastering its complex Frankenstein nature. That orchestration is expanding. India is currently executing the Super Sukhoi modernization program, pushing the fleet toward near fifth-generation standards. The new Virupaksha ASAR radar utilizes gallium nitride technology, drastically boosting detection range to 400 kilometers. With this expanded vision, a single upgraded MKI can track multiple targets and simultaneously launch up to 5 lighter BrahMos NG missiles. As Hindustan Aeronautics Limited rolls out these systems, the aircraft will reach 78% domestic indigenization. While the titanium bones remain Russian, the mission computer, radar, and weapons are now firmly under sovereign Indian control. In modern combat, the ground is won by whoever controls the sky. By turning a foreign airframe into a platform for indigenous innovation, the Indian Air Force ensured its backbone remains a formidable regional monster.